Water. Okay, so that gave me a chance to start the camera again because I ran out. Unfortunately, I had it on batteries and it ran out. But someone's kindly lent me their laptop charger, so it's now in 2 parts if you want to see it on YouTube. Studies the normal reading process. So I think we've already said that things are different if you're in a different language. So if you're in Italian, where there's much more regularity of the orthography, you will find that when you're reading, there is going to be much more reliance on the middle parts of the brain, whereas when you look at English, you'll find there's more activity in the posterior, in the back, in the visual cortices. Why is that? Oh, I thought you were going to tell me why it is. Anyway, why is that? Why is English activating all these parts of the brain? Hang on. Let me know. That lady there, go on. Yes, and that's basically because it's not so regular. You can't work it out from the phonological mapping. It's completely pain, and I apologise to anybody who's had to learn English. It's one of the most difficult languages, I'm told, in the world. Interesting, maybe, because a lot of those differences relate to historic events, but still annoying. So what happens in atypical readers? There are some studies that have been done with children and with adults with dyslexia, but it's still a very contentious area of research. So those of you who are thinking of doing an essay on dyslexia for your brain, mind and education assignment, you've got quite a choice to choose from. You can say, okay, magnocellular theory, maybe executive function, maybe I'll do temporal processing theory, maybe I'll go down the phonological deficit theory. You know, I would sort of advise you, well, you can either do all of them in quite a shallow way, which might be a little bit dissatisfying, or what would probably be better and more manageable would be to just focus on one. Mention the others, show that you're aware of them, but otherwise just focus on one. There are all sorts of brain differences that you can see when you look at dyslexic readers who have been given a diagnosis compared with those who haven't. The question is, what of these are meaningful? You know, does it mean anything about the causation of dyslexia? You know, can we say that one of these bits is broken? Well, it's kind of difficult, really. The cortex being so plastic, I mean, you'll notice that a lot of these, not most of them, are cortical regions, and the cortex, you know, becomes regionalized. It develops these specializations in terms of different regions. Partly it's genetic, but it's very much oriented by experience as well. So you might be able to pick up some similar differences in regions of activity or anatomical differences from different approaches to education or different standards of education. It is tricky. I think the magnocellular system deficits, and I've had to put this down here because I have to try to give a definition of this. Visual motion is sensed by a special set of visual nerve cells. The magnocellular system controls visual attention and eye movements. This is what the magnocellular system is supposed to be about. So, you know, maybe that explains why some dyslexic readers have this sense of visual interference sometimes and things shifting around. Maybe they're having trouble orienting their visual attention. And there have been all sorts of experiments that have been done to look at differences in binocular vision, their ability for the two signals to become integrated into a meaningful enough visual signal for them to decode it. So magnocellular system deficits is a theory all of its own. I mean, these problems in the cerebellum have been linked to temporal deficit problems, so they're actually in the timing of the frequency information, or maybe just timing. There's two camps on that as well. Differences in the corpus callosum might be something to do with left and right hemispheric communication. Remember, you're seeing this shift, aren't you, from right to left? Maybe that's related somehow to these problems. And I mean, these other ones are sort of classic language reasons that activate. And if they're not activating, does it just mean that they're somehow not being programmed so efficiently? They're not able to program themselves so efficiently? But this is all very, very debatable, and it's open to a lot of argument. Yes?
Well, about this scientific theory about dyslexia, I know that one scientist has introduced an improvement test in order for diagnosing the dyslexia, not only dyslexia, but ADHD also. Do you believe in the accuracy of a test like that?
Well, I don't know the test you're talking about, so it's difficult for me to say, but I would find it, I think the general consensus at the moment, people feel confident enough to be able to write that the general consensus is that dyslexia is not caused by visual impairment. Okay, so that seems to be the general consensus. There was a lot of popularity in those theories going back sort of 20 years, but now it's much more shifted towards auditory, well, not auditory, but phonological deficits. But there are still, you know, John Stein still pushing the magnocellular system idea. Yusha Goswami is very keen on the temporal frequency information, having trouble with decoding the frequency information in terms of its time sequence. I'm really pleased I don't work in dyslexia, actually, because it seems to be sort of place where you can easily lose friends, I think. So there are some, well, I've said recent biological theories, not quite so recent if it's 2005, but still a paper worth looking at, Beaton, because it's a nice sort of summary of those ideas. So I want to talk about cause now in terms of dyslexia, but actually this conversation is quite important for anybody who's looking at developmental disorder, because it's about how we about cause with respect to developmental disorders. And this is I would really recommend this book by John Morton. Morton and Frith are the pair that produced that standard cognitive neuroscience sandwich of brain, mind, and behavior. So I kind of feel like they're almost the founding mother and father of cognitive neuroscience in some respects. So I have great respect for John Morton. And you know, he's saying you really have to look at the behaviors that are observed and ask yourself if they align with the potential causes as they might operate within a brain-mind behavior model or a brain-cognition behavior model. So let's start off with the phonological delay or phonological deficit. I mean, again, you know, you're going to find papers that are arguing about whether you should talk in terms of delay or deficit, but generally speaking, this is about a problem with your phonological coding. So let's say up at the top we've got some sort of genetic difference, and that could give rise to a brain difference, and that brain difference is interfering with your phonological decoding, your phonological processing. So, for example, when you hear rhymes, you might have difficulty hearing the difference between or telling me whether two words rhyme, because you've got a phonological decoding problem. You can't actually hear, well, you can't determine the difference between these two sounds, if you like. It's not necessarily an auditory problem. I don't want you to think this is a sound problem. You're actually having trouble decoding the sound information that is coming in. Okay, so it's not like a deafness issue. It's a problem with decoding that sound information. And if that's true, then you would get to a point of actually having trouble with this. I'm not sure what that not learner means, but you're having trouble with the phoneme grapheme mapping, the thing that maps between the sound representation of the phoneme and what you're seeing in terms of the representation. And if that's a problem, that would definitely cause a problem with learning to read, okay, because you're seeing these letters, but when you try to turn them into sounds, you can't really do that because you're having trouble understanding about, well, not understanding, you're having trouble processing phonologically and turning these into phonemes, yeah? But if that's true, then there's all sorts of other things you'd expect at the behavior level. So this is our brain difference, our biological difference has given rise to some sort of cognition problem. And now we've got all these behaviors that you might expect if we've got a phonological processing deficit. And one of them is that phonological tasks are difficult. And we do find that a lot of dyslexics have trouble telling you whether something rhymes or not. When I say trouble, I don't mean serious trouble. I mean differences in response time. There might be like a few milliseconds, but it's statistically significant, a few milliseconds slower than somebody who has not got a diagnosis of dyslexia. They would also have problems with naming, because it's similar processes that are involved when you see something, you want to turn it into an auditory signal. So this is a boat. They might, a little bit longer because they have to think about the phonemes. You'd also see some spoonerisms that would be difficult because there's an expectation of how semantics should generate particular types of words. So if you see a semantic context, then you would straight away jump into a particular word because that direct route is in a way easier for you to use than phonologically decoding, because you're dyslexic, so you're having trouble with phonological decoding. So you use semantic contexts. You rely on them more heavily. And so when you see something like this, you have hissed all my mystery lectures and tasted a whole worm. Someone who's dyslexic might have trouble saying that. They want to say you've missed all my history lectures and wasted a whole term, because that makes sense. And that semantic context is, it's more tempting for them to try to say that, because they have trouble actually decoding it bit by bit and seeing, oh, that's hissed, it's not missed. But then another theory, which has been put forward by Paula Talal, is that it's a timing problem, and it may be involved with magnocellular systems because they're not necessarily sorry, my voice is cracking up a bit here. So magnocellular abnormalities can produce timing problems, and if that's the case, so it's not like a visual processing, but it's actually a timing problem, then you would get an interference in terms of how these phonemes were coming together when you were hearing them and when you were reading them. So that interference caused by things becoming merged temporally in time would be evident in a phonological processing problems, which gives rise to all these things that we can see them. Okay, that's fine. So this part of the theory is fine. Yes, magnocellular abnormalities can give rise to phonological processing problems. But do we see these things? Do we see poor speech development? Not really. Do we see poor motion detection? Well, not really. Do we see poor tone discrimination? Because if you're playing different tones, the tones would sort of merge if you were having trouble with your temporal discrimination. And so, there are these additional tests that you can use to test this theory and to question it. Another one is skill automation. It's really important that when you're reading that you take your process, whatever it is. It might start off with phonological decoding it step by step, but after a while it's got to become automatic. It's got to become really quick. And if you're having trouble making things become automatic, then you might see different problems. I mean, that could be caused by problems in the cerebellum, and we did see there's some problems in the cerebellum, so that is an issue. That would give rise to speech motor area problems, like Broca's region perhaps. But also, it would, from that, you would give rise to phonological processing problems. And all of that is fine, because we know we have these sorts of phonological processing problems, and the grapheme phoneme system is not learned. That's my problem with that sentence. I should put an is in there. The grapheme phoneme system is not learned, and all of that appears to be true, but that cerebellum difference is also going to give rise to a whole load of other issues as well. It's not just going to be this that doesn't get made automatic, it's going to be other skills as well. For example, you might see balance problems. Well, balance problems can occur with dyslexia, so they can be comorbid, as we say, with dyslexia, but not always. We might see problems with fine manual dexterity. Well, sometimes you see them, sometimes you don't. They might have problems with time estimation, and that's even more unusual, really. So by looking at it in these ways, you can think critically about these theories and start asking yourself questions that can help sort things out. So this brain-mind behavior, this brain cognition behavior model allows you to think more skeptically and scientifically about these theories that are being put forward. And then we have Stein's ideas about visual damage and these problems with binocular vision convergence, so actually having trouble bringing the images together on the page. And again, this can be a magnocellular deficit, similar to the temporal processing problem. But if this is true, then you're going to see visual performance problems as well. So it's not just going to affect your reading, it's also going to affect other types of visual tasks. And these are, there is some evidence for it, but it's difficult to be sure of it, really. So, yes, it would give rise, I think, yes, actually, I'm not quite sure there should be, I think there should be another, there should be an arrow between there and there, sorry. So, yes, that should give rise to that, and we get all these wonderful things that we do see, these problems, but it would also give rise to other issues which we don't see, such as visual performance problems. Right, I'm going to give my voice a 5-minute break now. How much more have we got? Give me some water. Has everyone signed the register? Everyone signed the register? Hello.
I was wondering if I could do my poster and assignment on depression in the brain, because we haven't really done.
Yeah, I think you can.
Just because we haven't really.
I can give you a license to do it, that's fine.
Okay.
I mean, depression is not something which education has concerned itself about, but it is increasingly under pressure to do so.
Yeah.
So it's becoming an issue, children's mental health.
Yeah, because I wanted to do it on the poster we were done, but the assignment on doing children and adolescents.
Yeah.
So I think, yeah, it's something that is very relevant.
Yes, I don't know how many, I mean, you may end up having to do it in adults, because I'm not sure how many studies will be done with children.
That's quite a lot of adolescents, but not yet.
Yeah, adolescents. Yeah, adolescents.
I just wanted to check because we haven't really done it, so I didn't know if it was too.
No, that's true. No, that's good. Okay. Hello. Do you mind if you work?
do some placard replacement.
Placard replacement. Sure, yeah. Just a couple of minutes, yeah? Yeah. You're welcome. Right. Thank you. Interventions. So we've come a long way, and we know something about dyslexia. We've got some results, we've got some theories. Does it have implications for education? Well, possibly, because we've got quite a few interventions now, and one of the best known, because it's available commercially, is Fast Forward. And this has been developed by Paula Talal, and the idea is that if you've got temporal processing deficits, then you can train and become faster and become more temporally again, better temporal resolution with timing. And it is supposed to develop memory, attention, processing and sequencing, the underlying cognitive skills that are supposed to be required for reading, or some of them. I mean, there are many other skills as well, but it's focused on those ones because they appear most related to this proposed issue with temporal processing. And the advert says, learning techniques are based on decades of neuroscience research, get results in as little as 3 to 6 weeks. Does it work? Well, there's a well-known study by Temple 2003 that shows both improved behavioural results, so these children's reading is getting better, but also the activity in the brain regions are reverting more to what they should be, if you like. So the differences between the brain activity in the children with and without a diagnosis of dyslexia are reducing. But after a lot of initial enthusiasm, some negative reviews have come through, and in fact, the latest conclusion, looking at literature, is that it's really very difficult to say that Fast Forward has a good, solid base of evaluative, scientific, peer-reviewed research behind it. It's very arguable. I've got to be careful because I just know this is going out. Yeah, the Americans love to litigate. Hello, yes, Maria.
Do you know if there is any difference between training Fast Forward in context compared with training Fast Forward without context?
How do you mean by context?
Context, semantic context. I mean.
No, I don't. No, I don't know.
Because I have read something about that.
Yeah, I mean, I think one of the problems, in fairness to the Fast Forward program, one of the problems with all these evaluations is that they're not able to test across the range of different ways in which an intervention might be applied, or across a range of different learners of different abilities. And therefore, at the end of the day, you can say it's worked or it hasn't worked for this in this particular situation. And it's very difficult to reach a general conclusion about whether it's working or not. So, some of the studies show there is an effect, some of them don't, essentially. Other interventions, though, have also shown remediated reading and brain activity. So, at the very least, these studies, such as Eden's study, Guinevere Eden, who targeted phonological training, and also a study by Shaywitz, they show an improvement in reading, and they show remediation of the brain activities associated with the problems. So at the very least, what these studies are doing is showing us that the brain is plastic and that education can work to both resolve the behaviour and the brain activation related to that behaviour. But if you believe the brain is plastic, that's kind of hardly surprising, I guess. Perhaps more exciting is the fact that brain imaging may become used as part of the design process. And one of the games that's already sort of received part of that treatment is Graphagame, which is produced in Finland. And although it's originally in Finnish, I think it's now available in all languages. And it's all about this grapheme-phoneme mapping, the mapping between the way it looks and the way that it's supposed to sound in terms of these individual letters. Or individual, graphemes. And they vary it according to the frequency and the consistency of the grapheme in a particular language. So, if TH occurs more in this language than another language, then you're going to be trained more on that. And it's also adaptive in the sense that if a child is having particular difficulties and they're showing particular confusions, then those will repeat themselves more often. And BREM used fMRI and EEG together, so you then get good spatial and good temporal resolution, because fMRI is great for spatial, not good for temporal, and vice versa with EEG. But more and more people are using these two approaches together. And what you find is this occipitotemporal region that we saw before, sometimes called the visual word form area, becoming what appears to be related to the improvements that you see using this software. Oh, sorry, I didn't mean to come on to him. And I wanted to show you a picture of that, actually. I didn't seem to have, I'm not showing it. Oh, it's a shame there's not a picture of it on there. But it is a particular brain region here, and we've already come across this parietal temporal region near Wernicke's area. And it's basically, we saw in the previous study with Turkeltaub that the more that region had activated, the more capable the children had become phonologically and in terms of reading. And they're saying, well, you can see from the brain images that this software appears to be really targeting that region. And having identified that as a sort of neural marker of performance, then it is theoretically possible to produce new versions of this game that increase that activity. And if you can do that, then you've probably got a much more effective game at remediating reading problems. So it's quite an exciting idea, being able to use neuroimaging as part of the design process for educational technology. And then, of course, there's this awful question that we will come across much more in the Issues in Neuroscience and Education unit. Does dyslexia exist anyway? Well, this gentleman thinks possibly not. Julian has been, I mean, he's probably one of the people who are sort of brave enough to start asking this question out loud to begin with. He was on a Channel 4 documentary about 10 years ago, and it was called The Dyslexia Myth. And that's a very provocative title, but it's good to have this issue on the table because we don't really have any neuroscientific or genetic markers that will help us diagnose dyslexia. These interventions that I've shown you that are good for dyslexics actually are good for normal readers as well. And you can see that the brain regions that are associated and the brain activities that are associated with dyslexia can be remediated by educational interventions, the same educational interventions that you would give to normal readers. So, you know, plus the fact that we're still struggling to find the sort of genetic cause in terms of those brain-mind and behavior models that I showed you. There are questions that need to be asked. And I remember, particularly with reading, I mean, speech is a different issue, but we tend to think about dyslexia as a problem with reading. Reading is something which only really a very small minority of our species has been able to do up until very recently. It's something which is culturally transmitted. It's something which varies in terms of the way it's done all around the world. And actually, it's not likely to have been selected for at all by evolution. And therefore, it's quite an artificial behavior to indulge in. So therefore, all of those things together, you know, might make you think, well, scientifically, does dyslexia exist? And if it doesn't, you know, if there isn't a scientific basis for it, there are other questions we need to ask, like, does it actually help us? Is it a helpful label? Does it help us differentiate between children with different reading difficulties? Are we ending up with children with reading difficulties here and children with dyslexia over here? Are these two different things? Because if it's just the same, then that doesn't really make sense. And you know, if somebody's got a dyslexic diagnosis, does it inform them how to deal with that reading difficulty in a way that's different to any other sort of reading difficulty? Not really, not very much. You would probably conclude. And then to what extent should the dyslexic diagnosis result in the differential allocation of resources? So, you know, does it, in terms of social justice, does it justify have this person having more support than somebody else without a dyslexia diagnosis, but still has a reading difficulty or some other sort of difficulty, actually? I mean, why should we have this approach for reading? Should we not have this approach for music? I don't know if there's a music-sissy or something, or sportixy, or some sort of some sporty, or something. You can imagine sort of a word that you can make up that would cover other subjects and you know, basically indicate that there's a weakness in this area. So there's some real questions to ask about this. And my feeling is that we're reaching a sort of a crisis point, because at the moment this label is providing a lot of it helps us allocate funding, and there's a danger that if we remove it, we're going to lose the funding. On the other hand, its scientific value is really being called into question, I think, at the moment. So it's a very difficult situation that we find ourselves in. Yes.
A couple of quick questions. First of all, do you think that someone can be taught out of dyslexia, as they could be taught potentially out of low literacy levels?
Well, I don't know the answer to that question, but I think it's something you could ask yourself on the Issues in Neuroscience and Education unit and see what other people have decided. Because there are certainly a lot of scientists who would say that is probably true. Yes, that there is no more sense in which dyslexia is trapping you onto a biologically determined course than any other type of reading difficulty. Okay. I'm gonna skip this break. Is that okay? Because I should be on topic. But why were we having 5-minute breaks? Well, the reason why I've been doing this, first of all, actually, has anybody got any questions about language before we go into my teaching and learning notes? Language, reading, speech. We've covered a vast territory here very, very quickly. Okay. Yes, sir. Make it brief, though, Jade. Yes.
Okay. Has it been noted at all that certain words will trigger dyslexia more than others, regardless of the literacy level at which those words are based? Because
yes, in the sense that words that require more orthographic decoding are going to cause more problems. I'm not sure, but I'm fairly certain that is the case.
If that could be detached from literacy levels for a moment, so regardless of literacy levels, so you could have, say, words that would be associated with lower literacy levels, but because their coding will trigger dyslexia more, then surely dyslexia could be observable and separated from...
Yeah, except that most of our education approach at the moment is based on phonological decoding. So that seems to be a thing that we're actually teaching children more than anything else when it comes to reading. And yet we're saying the problems with dyslexics is they're having trouble with that. Well, that's our reading approach, that's phonics. So it's a bit of a difficult one. So the reason why I've been giving you 5-minute breaks is because the oldest effect that has ever been documented that might be of use to education is the spaced learning effect. That if you have something you want to learn and it's going to take an hour, it's better to do it in 4 15-minute sections and do something else in the middle. Now, of course, the problem with this is that what are you doing in the breaks? You know, because you're stuck here saying, what am I going to do? But maybe there would be a way around that. Maybe if I warned you, I said, look, can you bring your email along or whatever, so that you can do something useful in the 5-minute breaks, then maybe, you know, we could actually find this as a more efficient approach. It's an interesting one. I mean, at the moment, it is being trialled in schools. So one of the EEF Welcome grants is supporting a massive trial of this within schools. And the reason why we think it works is because unconsciously you are rehearsing the material and even the words are playing over in your mind. And in fact, relevant to this lecture, we see a region quite close to Brocker's area activating in the spaces. In other words, you're sort of have got this internal dialogue going on, even though you might not be aware of it. And, you know, you can go and do something else. You can go and work in the garden or whatever in between learning sessions, but actually you still appear to be learning during those spaces. So spaced learning it was discovered by Ebbinghaus in the 19th century, and it is possibly the most neglected psychological effect in education. Why ask you what you know about language terms? Well, to explain this in terms of brain networks, I've told you about Hebbian networks. And the idea of Hebbian networks are that neurons that wire together fire together. So what you really want is, if I'm introducing a new concept to you, it's going to activate neurons in a particular part of your network, okay? And what I'm trying to do by talking about the old concepts at the same time, saying to you, do you know what a grapheme means? And then you're giving examples of it, and you're thinking about, well, what do I know already? Then your old concepts are also activating. When your old concepts and your new concepts are activating together, then we get simultaneous firing on some of these neurons, particularly the ones that are connected to both areas, yeah, because they've got postsynaptic membrane depolarization. So there's actually that going on one side, and there's more activity coming in. So when you get many activities coinciding on a neuron, then that neuron becomes more efficient at firing. It means you need less activity in order to fire that neuron. In other words, you get stronger connectivity between those two networks. And that means that when you start thinking about your new concept, when you go out of here and you think, oh yes, you know, phonemes, phonological decoding, that's all to do with dyslexia. The old concept about what a phoneme is, and thinking, oh yes, I know what a phoneme is because I've looked in phonological dictionaries and we'd had a discussion about what phonemes mean, that will activate at the same time, giving meaning to that notion of phonological decoding. So in other words, it's really important to produce new knowledge and to be thinking about new knowledge alongside your old knowledge. And for there to be links, meaningful links, that link the new concepts to the old concepts. And that really only happens through having that sort of, or it can be encouraged to happen through a dialogue with your teacher who is talking to you about what you know already. So the old concept, when you come across it, is now more likely to activate the new concept, and the new concept is more likely to activate the old concept. You get these things being meshed together. The new becomes meaningful through its relationship with the old. This is not actually a stunningly new idea. This is Vygotsky. And in fact, you find that the ideas of Vygotsky in terms of working in the zone of proximal development Have you come across Vygotsky? Put your hand up if you know who Vygotsky is. Good, good, good. Okay. So that idea of working in the zone of proximal development, having a dialogue with the learner, finding out what they know, and then building on top of that is incredibly important. There is no conflict between Vygotsky and Hebb. What Hebbian networks do for us, what they've done for us, is to actually provide a biological mechanism, if you like, or an understanding of how the biology operates in order for teachers to be able to work in the zone of proximal development and to develop the new knowledge, building on the old knowledge, and how that can occur. Now, there are quite a few things that I should say. Hebbian ideas and Vygotskian ideas are not the same. Hebbian, for Hebb, the brain activity is formulated in terms of this theoretical framework of cell assemblies, you know, neurons that fire together, wire together, long-term potentiation. For Vygotsky, he talks about a semiotic mediation through speech. But actually the speech, when you're talking to a pupil, is firing those neurons. And although mental connections are not the same as neural connections, there is no conflict between Vygotsky and Hebb. And if you're interested in understanding more about the relationship between neural networks and Vygotsky's ideas, there is a wonderful article that's been written. It's in the bottom in the notes here in the slide. And it's been written by, amongst others, Michael Posner. And Michael Posner is an expert. He's very, very well-established neuroscientist who has given us a lot of what we understand about attention, actually. So we know we can take him seriously. And it's a really interesting article. And I think this article might be of particular interest to the neuroscience and education students. I would really recommend it. Right, so there you go. Are there any questions before we leave? Can I just say 3 things?
Yeah.
I know, but I did just say 3 things. I can't remember what they are, but I know that the people in the workshop will help me. The first thing is, we're encouraging you. There is a little bit of a note that says, you know, it's interesting for me to know your personal experience, your personal connection with this topic. You know, I just want to know, oh, I teach children with dyslexia or whatever. Sometimes people want to say, oh, I'm doing depression because I have a history of depression. Actually, that's not, I'm not sure that I should know that. Well, I don't mind knowing it, but the problem is that if you start declaring your medical history or your personal history on your essay, I don't really have control about who sees that essay, and I think it makes it more difficult sometimes to assess your work if you're giving out a lot of personal details about your background. So I'm sort of discouraging you from doing that. At the same time, if you want to study something which is personally significant to you because of your personal medical history, please introduce yourself. Say as a friend, a close friend of mine, or somebody I know in my family, or somebody I met on holiday, blah, 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 blah. So I'm not saying don't do it, but I would say just don't disclose that you are the subject, because actually it makes it more difficult. The second thing was, I don't want references on that poster to websites. I don't want references to anything other than neuroscience, cognitive neuroscience textbooks and e-journals, okay, electronic journals. Well, they can be print journals if you like, but e-journals are much easier. And there is a wonderful system, which we're not going to have too much time to demonstrate now, but I want to make you aware of it. The place to go to find out your knowledge is to go to the library website. And when you go to the library, go to the databases, and down at the bottom of the databases is the best database of all, which is Web of Science. And you can put anything inside there. So if you're interested, for example, in dyslexia, yeah, very good. Or actually, you could just probably just put in brain. You could even put in review. Yes, 209 pages we've got here, and many of these are likely to be relevant, and sometimes it's good to put in review as well, because that might help you, because review articles are particularly useful to you. Only got 23 of those. Yeah, some of those may be particularly relevant. And also, you might, if you haven't tried it yet, I would really recommend EndNote. Find out about EndNote because it allows you to automatically download your references into a citation manager, and then you can insert them automatically into your essay. If you learn to do that now, it'll be fantastically useful when it comes to your dissertation. So I really, really do think about that. What was the third thing I had to say? What was it? Have I said it? Oh, okay. Diagrams.
No website, no.
Yeah, I think that was it. Okay, that was it. We talked about a few other things in that workshop, but those I think were the main things. Are there any questions about anything? And it's much better to ask me now because the reply might be relevant to everybody. When is the poster due in? 23rd, is it? Okay, so you've got a couple of weeks. I'm going to see you next week if you have any further questions. But any questions? Okay. Have a good evening. I hope my voice is still here tomorrow. See you tomorrow.